We live in a time of global transformation. The Energy Futures podcast explores how we can accelerate the expansion of clean energy technologies and reduce our reliance on fossil fuels. From heating and cooling our homes to moving around our planet and beyond, we bring together researchers, scientists, business leaders, and communicators to exchange knowledge and try to answer one important question. How can we create a sustainable energy future for all? This podcast is produced by Energy Futures Lab of Imperial College London.
What are the major challenges around decarbonising our homes, and what impact does this have on the UK's net zero targets? Today's episode is hosted by Anastasiya Ostrovnaya, a senior research and teaching fellow at the Centre for Climate Finance and Investment at Imperial College Business School. Her research spans across climate risk taxonomy, with an impact study on the financial risk of climate change to corporations. Her guest today is Matt Lipson, the Deputy Director of Undaunted. With strong expertise in strategy, team building, leadership and market research, Matt holds extensive industry experience in generating renewable energy for homes. In this episode, they discuss challenges the heat pump industry face in line with net zero targets, government policies on heat pumps, initiatives, new technologies and installations in UK homes, and the driving force behind the market.
Hello, and welcome to an Energy Futures podcast. My name is Anastasiya Ostrovnaya. I'm a Senior Research and Teaching Fellow at Imperial College London at Centre for Climate Finance and Investment. Hi, Matt.
Hey, Anna.
Do you want to introduce yourself?
Sure. My name's Matt Lipson. I've been working on climate since 2008 when I actually did the Environmental Technology Masters at Imperial. And I've been working in different bits of it since then.
Fantastic. We're here today to talk about heat pumps. Heat pumps is identified as one of the major technologies to decarbonize heating. And domestic heating in the UK accounts for about 18% of total emissions, which we need to reduce to net zero by 2050, which is put in the law. So why is it such a challenge?
I mean, it's not. We just need to crack on. We haven't really put much pressure on it so far, but progress is starting and accelerating very quickly.
So what are the main obstacles? So according to the statistics, about 60% of households in Norway have heat pumps, and about 1% of UK household has heat pumps. Clearly, just cold weather is not the main obstacle. Why do people not adopt the technology here?
That's a good question. I think there's a range of reasons. The first and the biggest reason is we've got a gas grid, and we've been focused on natural gas since we found a load in the North Sea. In the 70s, not many people had gas central heating, actually, a minority of homes. And pretty much everybody does now, 85% of homes. Gas has always been cheap, plentiful, very simple. So we trained a whole bunch of heating engineers to install boilers, gas boilers. There are also oil where you're off the gas grid. And we have this incumbent technology and a whole set of systems in place that are there to maintain the systems, service them, sell new ones. So we've got a very mature industry. Whereas Norway, I don't think, has a gas grid, and they don't have cheap, plentiful supply of gas because they sold theirs and put it into National Wealth Fund. So there's a big difference between us and Norway, but physics is the same, and it's even warmer here, so it's a bit easier.
But a lot of households are still very reluctant to go with that. There are some government policies in place to support it, right? Last year, the government announced £7,500 subsidy for installation of heat pumps. Is that enough?
Yeah, I mean, I think when we think about heating, I think the first and most challenging problem at the moment for a lot of homeowners is, if you ask them what they need to do to kind of play their role in climate change, they don't actually know what to do. Lots of people say, well, I'm doing everything I can. I recycle. Obviously, it doesn't have very much to do with their carbon footprint. So I think there's a kind of information requirement where everybody should know that most of the carbon footprint of their home comes from their heating system. 85% of the energy they're using at home is for heating and hot water, and that's for most homes, as we just said, is by burning a fossil fuel, literally having an explosion box in your kitchen that's kind of burning, dinosaur farts, frankly. And they should be thinking about, when they replace that heating system, to replace it with something that's clean, green, costs less to run, and saves the planet for their children.
Do they really cost less to run? Because UK is one of the outliers in terms of electricity to gas price ratios. So in the UK, it's about 4 times? Electricity is 4 times more expensive than gas per unit of power. And that's mostly driven by taxes and levies, not by underlying condition.
Yeah, as you just said, that's mostly driven by things which are not to do with generating electricity. As we move to a zero carbon electricity system, the UK now has a 2030 target for clean electricity. There's an upfront cost with building a wind farm or a solar farm or a nuclear power station, but once they're built, actually the running costs are very low. So the whole cost structure of our energy is likely to change, whereas, as we've just seen with what's happened in Europe, the cost of gas is very, very volatile and has increased dramatically, as we saw in the last few winters. The magical thing about heat pumps, air source heat pumps can be 5 times more efficient than a boiler, higher in some instances, lower in others. That's if you get a good design of a system and a good installer and you operate it efficiently. So even though electricity is 4 times more expensive than gas at the moment, actually you can still save money on your bills if you install a heat pump. And actually that fourfold differential between electricity and gas, government have committed to reducing that. I think in the Netherlands it's 2. So there's nothing about the physics that means it has to be so high. And so we would expect that to come down over the 15-year lifetime of the heat pump, 15-plus year lifetime.
So I have 2 challenges for you here.
Only 2?
Oh, well, for now. One is when you're talking about air source heat pumps, which are 5 times more efficient, coefficient of performance, that sounds quite a lot. If you kind of look at general sources, ChatGPT, it says 3.5. How do we achieve that 5? And does it depend on how well insulated your home? Is it new home? Is it old home? Clearly, that would matter a lot.
Yeah, great question. So ChatGPT, very interesting. But there's also something called Open Energy Monitor, which is open monitoring, so open source. And they monitor heat pumps all around the country. So you can just go check that out. And what we should be looking at is the COP, the coefficient of performance, is like the current speed your car is doing. Whereas what we're thinking about is the average speed across the year, which is called SCOP, or seasonal coefficient of performance. So I was talking about the SCOP, the seasonal. So averaged across the year. It depends. If you get a good system design and a good installer, then your system can be very, very efficient. If you like with anything, if you just attach a heat pump to a building and don't think about the rest of the system, the radiators, the pipe work, the control system, and how you're using that system, well, it won't be very efficient. Like if you buy a super efficient vehicle and drive it like a lunatic, it's going to be super inefficient. So there's a complex kind of set of things. The statistics I was quoting were from, I've just recently left a business called Heat Geek that I work for, which is an absolutely amazing place where they train heating engineers to get out of gas and get into heat pumps, and then they equip them with tools so they can do their best work. They monitor the performance of every heating system they install. Their average performance is, when I was there, was 4.3, which is 5 times higher than a boiler. The average boiler efficiency is 85%. So it's 4.3 versus 0.85. So 5 times better. You could do better than that. We're just at the beginning of a massive wave of innovation, I think. And obviously, if you're replacing a boiler, it's probably less than 0.85% efficient, 0.85 or 85% efficient. In terms of the fabric, I think this is another area of kind of myth busting that's really important to do. The average efficiency I just quoted for Heat Geek, that's across any kind of building. And so ask a very capable heating engineer and they'll tell you this. It's about designing the system appropriately. So in simple terms, I'm not a physicist or an engineer, but in very simple terms, if a building loses some heat on a cold day, a warm building's losing some heat, you just need to match that heat input, right? So you need a heat pump. So if it loses 4 kilowatts on a cold day, you need to be putting 4 kilowatts in. So you need to match the size of the heat pump to the heat loss of the building. So that's an important thing to get right. And then as long as you design that system appropriately, so typically lower temperature systems perform more efficiently, which is, again, is just basic physics. So the right way of designing the system is large radiators if possible, low flow temperatures, so the water flowing around this system, keep that nice and low. I mean, still warmer than you'd find comfortable, so 45 degrees, something like that, which is pretty hot for a human. We tend to like our homes about 20 odd. And that will gradually get the home warm, nice and warm to temperature, and keep it there. And then as long as you're matching the heat loss of the building to the heat input, you can be kept nice and warm at a very, very high efficiency. So coming back to your point about is that only for new builds? No, the average efficiency I quoted for HeatGeek is for any kind of building. That includes old and uninsulated buildings as well as new buildings.
I'm very excited to hear that. I want to come back to installation and efficiency in a bit, but I wanted to address the electricity costs first. Yeah. So you were talking about that more deployment of renewables may bring cheaper electricity to us. But in UK, the electricity price is set by basically marginal producer. So in spite of the benefits of renewables, we're still very much exposed to the gas prices and paying very high price for that. So do you think that's going to change?
Well, if we're going to solve climate change, we might have to stop burning gas.
Okay.
But I guess we could burn it and store the CO2 and CCUS. But yeah, I think that may need to change at some point. But there are loads of other reasons that the running costs are high at the moment, I think. Like many systems are not installed very efficiently. The green subsidies you mentioned are all added to the electricity bill. There's various discussions within policy circles around, maybe we could put those taxes, which is fundamentally what they are, somewhere else. If you're trying to get people to stop burning fossil fuel, perhaps you should try and make the fossil fuel more expensive and the clean green electricity a bit cheaper. But regardless of that, as I said earlier, your running costs can still be lower already with a heat pump.
But that sounds good. I think at the headline price, a lot of heat pumps still can be more expensive. Maybe the best-in-class installation and best-in-class heat pump tariff, electricity tariff, which already do exist. That brings the cost lower. But at the headline kind of electricity, cap, it's still quite expensive.
Yeah, I think one more thing on that that's very important. Obviously, when the wind blows and the sun shines, there's lots of renewable electricity on the system. And what we're going to see increasingly is that the cost of electricity will vary with time. As you just said, the marginal price set by when you, on those few days a year in the future system, when you might need to be burning maybe natural gas, maybe hydrogen, or doing something different on a few days a year, which will push the price up. But when it's very windy and sunny, low electricity prices. So there are ways of using your heat pump that use the cheap electricity to heat your home. For example, you could store electricity in a battery when it's cheap and use that to power your heating when it's more expensive later in the day. So, there are other ways of reducing your running costs, and there's quite a lot of innovation happening in that space already. I imagine in Imperial all over the place, but certainly already in industry with businesses like, there's various, Octopus, Aera, Ovo, HeatGeek, many businesses looking at how you can manage the way your heat pump uses electricity to minimize your running costs.
So one thing you talk about a lot about installation. So last year, by what I found, there were 100,000 installations, when UK government's own target is 600,000 per year by 2028. It's in 3 years. Can we get there? Can I get a good installer?
So there are, obviously, we have 1.5 million boilers installed every year in the UK. So there's tons of people who know how to install heating systems. The problem is they're focused on gas. So, a key thing we need to do is to encourage them and enable them to switch from destroying the planet to saving it, which most of them would like to do if you can make a good case to them. We need to retrain people. Actually, if you're a good heating engineer and you can design a good heating system, learning how to do a heat pump isn't a massive jump, and you can learn that in a few months very easily, and improve your heating system engineering generally. So there are online training available, like from HeatGeek. This is one of the things that they do. And if you're looking for a heating engineer, there are many companies that sell heat pumps. Obviously, I'm a little bit biased. I worked for, I believe, the best heat pump installation business, which is HeatGeek. You go to heatgeek.com, you'll be able to find an engineer in your area. But there are others, Octopus, Aera, OVO, British Gas even are trying to do this. And increasingly there are many, many, many people doing this. But you're right. I think at the moment, the biggest challenge is we don't have enough installers and they're not, able to install brilliantly in every home. But that's changing very, very quickly because for the installer, it's a better job, right? They can basically make more money, doing more interesting work, feeling better about themselves because they're saving the planet. It's more interesting because swapping a boiler for another combi boiler is just not particularly intellectually stimulating, whereas figuring out how much heat a home loses and how to organize the heating system to maximize comfort for minimum cost is actually a really interesting problem. So the best engineers want to get into that and they find it fascinating.
People are still concerned about their comfort during winter months. So that I have an example. A friend actually stayed over yesterday, and their heating system is 20 years old. They just moved into this house. It's built in 1970s, brick construction, but with a lot of extensions, and they're quite leaky. And the windows are leaky. And their main concern is, are they and their kids going to be too cold in winter? What should they install? Can they install heat pumps? Is it going to be efficient? Or what kind of upgrades would they require? Do you know?
It depends on their situation. They don't need to do many things, but the first step would probably be to get a good heating engineer to come round, have a look at the home. Again, I've just mentioned all the various companies. Now, typically, you're probably going to need to pay someone if they're going to do a good job. I mean, high-skilled people generally aren't free. Different businesses have different commercial propositions in terms of when and where they make you pay. But fundamentally, it's not free to get a highly skilled person to come around to your home and figure out what you should be doing. But if they want a heating system, they should get a heating engineer. And what they tend to do, those engineers, is walk around the home and measure the heat loss of each room. And there's a standard kind of way of doing that, which enables them to sort of help the homeowner figure out how much heat input they need to match that heat loss. There's very, very few homes that couldn't have a heat pump in the UK. It's not always the best solution, because if you live in a high-rise block of flats, probably not the right solution for you. Possibly is okay on the ground floor where you've got a little bit of room outside. But for the vast majority of homes in the UK, an air source heat pump is a really good solution, which is why we've been talking about it so far.
Under normal circumstances, and typical British winter where it's like plus 12 degrees outside or plus 7, exactly. It's going to be fine. Yeah. When it goes minus 5 or lower, that's where people are really anxious about being cold, and especially their kids being cold.
Yeah, okay, so will a heat pump heat your home? Yes. As you said earlier.
Sufficiently warm?
Well, Norway's colder than the UK, right? And 60% of homes have heat pumps there. So it's not difficult to heat a home with a heat pump. You could heat a shed in the Arctic with a heat pump, and it would be fine. I think you could probably heat a spaceship out in space with a heat pump. In fact, they probably do heat spaceships with heat pumps in space, where it's obviously very cold. So yeah, you just need to make sure you get a good heating engineer. And actually, most of the businesses that are good at this will guarantee that you are going to get comfortable, or they'll fix it. When you install a heat pump, your installer has to follow some guidelines from MCS, and that has a design temperature in it, which is up to the homeowner, how warm you want your home to be on the coldest day of the year. And that will affect how big a heat pump you need and your running costs on those cold days. But fundamentally, you could heat, as I say, a shed in the Arctic with a heat pump and keep it nice and toasty warm.
Okay, sounds fantastic. Can we pivot now to the upfront cost? Because that's one of the biggest obstacles, right? I don't know how many people really check the running costs and anticipate and calculate the NPV of, the system. Majority of people are cash constrained, may or may not have enough savings to cover the upfront costs. And that's one of the biggest factors in decision making on the system. So how do the costs look at the moment?
Yeah, at the moment, installing a heat pump system, by which I mean a heat pump, a cylinder, some radiators and some pipes, and a control system, is more expensive than swapping a combi gas boiler for a combi gas boiler, right? But what you'll find is that, as you just said, your friends moved into a house, they're worried about the heating system. It's probably undersized for their home, or it's not very well matched, and they're worried about it. So lots of homes have quite bad heating systems. When I used to work at the Energy Systems Catapult, we found that the vast majority of people in those homes didn't have very good heating systems. They weren't very well designed, they weren't that well installed, and the running costs were much higher than they needed to be, and the comfort was lower than it could be. So actually, there's probably a lot of optimization you can do when you replace your heating system. If, for example, you're also renovating your home, doing an extension or something like that, adding a cylinder or moving a boiler, adding some pipe work, adding a few radiators, then because you get the grant, there's a boiler upgrade scheme the government has, which currently offers a £7,500 grant, and because you don't have to pay VAT when you install a heat pump on the parts and labour, because of that, actually installing a heat pump is about the same price as installing a new gas system. So, that's already the case. Now, those costs are going to reduce. As you said earlier, we've got tens of thousands of people buying heat pumps at the moment in the UK. When that increases 10x, you will see the prices drop because the businesses that install those heat pumps can buy them in bulk. You buy anything in bulk, the cost per unit reduces, and market competition will reduce the price to the homeowner. So there's already a good trajectory to get those heat pump installs very comparable to a gas boiler. And in some instances, as I said, it's already about the same. Having said that, it is a bit more expensive at the moment, but because the running costs are lower, what lots of people do is add the cost of the heat pump to their mortgage. So lots of homeowners own a home, they have a mortgage. If you add the cost of the heat pump to your mortgage, many of the high street banks will offer you cash back, thousands of pounds, and then you're going to be paying back for that heat pump over time. The good news is, on a kind of 5% 15-year loan, the repayments are actually lower than the energy bill savings you get from that five-fold improvement in efficiency. So, yeah, look, it's a new technology for the UK. It's like 40 years old in terms of how long it's been going. So, there are some instances where the upfront costs are higher at the moment, but they're coming down fast. There's also tons of other bits of innovation that are happening in the system that could see those costs reduce even further, which is obviously great news.
Like what?
Well, one radical innovation, as I said earlier, is to buy in bulk, right? That's what Octopus did initially, and then they obviously bought a heat pump manufacturer. And all of the larger businesses playing in the space are buying in bulk, and you get much better discounts from the manufacturers. The next is there's lots of innovation around system design. So, for example, if you've already got a cylinder in your home, you don't want to buy a new cylinder, well, you could reuse that cylinder, right? That's the sort of thing that you could do. And perhaps you don't need to replace all of your radiators. You can have fewer new radiators or no new radiators. It's a trade-off that the homeowner can make. A really, really good heating engineer should be able to talk you through these different options. And that was a really key one I just highlighted, which is, do you want to minimize your running costs, which you might have to upgrade more radiators, bigger surfaces at lower temperatures, meaning the system performs more efficiently. But that's a bit more disruptive and expensive up front. Would you prefer lower install cost but higher running costs, or the converse? Totally up to the homeowner, and a really good heating engineer can walk you through those different options.
Fantastic. I want to add one more innovations for the households which have a little bit of space. They can trade some space for reduction in cost, in the way that they would add some giant thermal storage, basically giant cylinder, to store hot water in the basement or in the attic, probably in the basement. And that would enable them to get actually smaller size heat pump, which costs less. That's one of the possible solutions as well.
I mean, there's so much innovation happening in the space. I know that at Imperial, we've been supporting some startups that are doing some really cool stuff in the space. For example, designing a smaller air source heat pump that goes on the wall in your home, does air conditioning as well, is not using the wet-based system. So if you don't have, if you've got storage heaters, for example, you're already using electricity, but you could get 4 times more efficient system by replacing it with a heat pump in that case. So there's a ton of innovation happening in the space that I think is going to really improve matters. There are also some really silly things we're doing at the moment. So, for example, we have planning rules, which are slightly ill-conceived. The concern from a planning perspective is that, as you all know, because you've probably got a heat pump at home already in the shape of a fridge.
Yes.
Yeah. When your fridge is cooling the food inside the box, it makes a little noise. That's the same noise as a heat pump makes in your garden. And understandably, we want to make sure that noise doesn't cause a nuisance. No one wants that. So we have some planning rules at the moment. But those planning rules aren't actually focused on the noise. So there's various assumptions embedded in the rules, like the system has to be small, the system has to be far away from your property boundary, 3 meters in Wales, which is obviously quite a large distance. And actually, if you're worried about noise, probably the planning rules should change to focus on a noise limit. And Nesta, I did some work with Nesta, but Nesta have been doing lots of work on this to try to remove that barrier, which makes it more difficult for a homeowner. You want to get a heat pump and suddenly you've got to get planning permission. Well, if you want it next week or in a month, how are you going to get planning permission in that time? Why should you have to apply? So there's lots of other issues that are making it a little bit more difficult than it needs to be at the moment, but actually they're gradually one by one being removed. So for example, on that one, as I said, they're worried about noise, but they're limiting the size and location of the heat pump. Well, actually, turns out a bigger heat pump could be quieter because you can put more soundproofing in the box and you can run the fan a bit slower because it's a bigger fan, moves the same volume of air by moving more slowly and therefore quieter. It could also be quieter for your neighbour if it was on the boundary wall pointing towards your home rather than towards the neighbour. So, there's some very simple things we can do to just make it a little bit easier for everybody and reduce the running costs at the same time.
I don't have a heat pump yet myself, but my neighbor actually installed one, and I can assure that it's actually very quiet. Moreover, it actually works in the winter when I don't spend much time outside. So it actually, they've had it for a couple of years and hasn't bothered me in this.
Yeah, we used to take people out on site and they'd say, well, is it on? Is it on at the moment? Is it, you can't hear it because it's so quiet. You have to kind of go right up and try to listen. And as you say, they tend to be their noisiest when they're kind of working their hardest, which is when they're taking a cold building to a warm building on the coldest day of the year when you're inside with the windows closed, and it's probably at night as well. So, yeah, you're right. I think, but understandably, people are worried about things they're unfamiliar with. Maybe everybody should go to Scandinavia on holiday.
Sounds like a good idea. I want to. One thing you've mentioned is the startups. And I kind of wanted to explore with you of what do you who is the driving force behind the heat pump revolution? Is it the startups or is well-established big hitters, utility companies that usually provide our gas and electricity? Where do you think the driving force of this market happen?
Well, if you look at the market, I think the most creative and innovative ideas are coming from smaller businesses. So as I said earlier, HeatGeek are doing some incredible stuff. So one issue you might have is if you've got a small home and you've got a combi boiler, no room for a cylinder, well, HeatGeek invented a mini store, which is so small, it's a store for hot water, and it's the size of a combi boiler. So you can remove your combi boiler, put the mini store in, and get a heat pump. Brilliant idea, and it's not something they're trying to sell. They've allowed anybody to manufacture those cylinders. Valent, I believe, and other large boiler manufacturers and heat pump manufacturers are looking at, can they start to manufacture these cylinders or these heat stores? So there you can see partnership being absolutely key, right? A tiny business working with a large business. I think it's this kind of ecosystem of different players that's very important. I guess it's quite hard, though, if you're a big business and you're selling a lot of gas boilers and a lot of gas, like British Gas, clue in the title. It's harder for a business like that to kind of stop generating revenue from that source and flip to a totally new market, which is in its infancy. And so arguably those sorts of large players that are already making a lot of money in the old world maybe are going to be less driven by innovation and less driven to find new and better ways of solving climate change.
Well, let's hope all these small companies will become major players in the market.
Like Octopus, who were small and are now huge and are doing incredible things with heat pumps. You can't, look anywhere and Google heat pump without them coming up. And Aera is a sort of interesting blend of the two. Aera comes from Scandinavia. You probably know the business already, and many of the viewers will. They are quite a small new business in some ways, although they've raised £500 million of investment. So on the other hand, they're quite large. They have, they bought a heat pump manufacturer. They're making their own heat pumps and they're selling a really great proposition to homeowners. And in fact, these businesses are working together. So when I was at HeatGeek, we were partnering with Octopus, with Aera, with Valent, with OVO, with others to try and just move the needle as fast as possible. So I think it's a team game. So at Undaunted, at Imperial, we've been supporting lots of startups working in this space. One of them, Anzen, make a solid-state heat pump, which is absolutely groundbreaking. Doesn't use refrigerant. It doesn't compress air to make the heat move from air to water. New technology, a bunch of whiz-kid engineers, and it does heating and cooling, very quick to install. It's a beautiful flat panel on the wall. You'll be able to see it if you Google Anzen. But it's one example of many, many innovations that are coming and are going to disrupt this market in a really good way.
So I want to pivot back to what role does financial system play in this low heat carbon transition? The upfront costs are really high. We're talking about adding the cost of heat pumps to the mortgage. Is that even possible? Is it easy? And is there a larger role that financial system and banking system can support this?
Yeah, I mean, I actually wrote a blog on exactly that, which I can share in the maybe the show notes. Most mortgage companies will let you add to your mortgage to do a home improvement. You could buy a kitchen, you could buy a bathroom, you could buy a heating system. If you buy a zero carbon heating system like a heat pump, many of the bigger players, like I'm talking about Barclays, Lloyds, HSBC, these very large banks, all of the others, NatWest, I don't want to go through all of them, are looking at funding and supporting people to go green. So it's already possible to do. It could be more easy, could be publicized more effectively. But yeah, that's already something you can do. And as I said earlier, if you add a heat pump to your mortgage, it's a kind of 5% 15-year loan on average. And that means your running costs will reduce by more than the repayments. So it's kind of a no-brainer to do that.
I see. That sounds really promising. And do you know the uptake of that? Do people know about this?
I think awareness is quite low. And I think, there's different points in time when people want a heating system. So if you're renovating your home, that's where the uptake is probably highest because it's a proactive, thoughtful decision. If your heating system breaks, where are you going to go? To a plumber, to a heating engineer. Now, those people need to be the advocates, and there's lots of work I think we need to do to make sure that they understand heat pumps, that they understand how to install them, that they want to install them because they have the business processes set up. And there's lots of work happening. And as I said earlier, HeatGeek and others are working on making that super simple for them. And the government are all over this as well. The government are really keen to enable gas engineers, heating engineers to get into heat pumps, which is the future.
Okay. And can consumer finance support that?
It can, absolutely. But consumer finance tends to be higher interest than a mortgage because it's unsecured. But you can already borrow and add a mortgage to those loans, and then maybe pay it off if you've saved up enough to pay off the loan, as you would for anything else you might put on a credit card or personal finance.
Yeah, sounds great. Some time ago, we actually had a discussion whether, for banks, making small loans is not the most profitable business. And the innovation which enabled a lot of small consumer loans like credit cards or car loans was actually in terms of collateralization. So pooling of the assets and kind of tranching them and selling them to different investors. And should there be a product which is like heat pump backed obligation instead of mortgage backed obligation, where heat pump loans can be pulled together and then sold to a long-term investors who have strong green mandates, especially because that can be classified as green finance.
I mean, I think the leaders in that space are the Green Finance Institute. They're doing brilliant work, lots of interesting ideas and very thoughtful publications. So they've said lots about it. I guess, fundamentally the issue here is about kind of motives and capabilities. The finance sector, I think, at the moment finds it probably easier to finance a large wind farm than, the equivalent number of homeowner heat pumps. So I think there's, as you say, work to be done to aggregate up those individual loans so it's easier for the finance sector to engage with it, but also they need to be motivated. So at the moment, the banks have some targets in terms of EPCs that they have to kind of green their mortgage.
What is EPC?
Energy performance certificate. So if you sell a home or rent a home, you get an EPC or you buy a new home. And it's kind of like letters like you get on food labeling, A to H maybe, or G, in terms of how good the energy performance of the home is. Unfortunately, the process they use to determine the letter is old and outdated and is really about energy cost rather than carbon. and has some assumptions in it. So it assumes that heat pumps are not very efficient, for example. So the national average heat pump efficiency is closer to 280% than 430%, which is why I keep banging on about how brilliant HeatGeek are. But as a result, if you install a poorly designed, poorly installed heat pump, your bills can rise. So your EPC letter can get worse. So the banks are told, get good EPC ratings for your property portfolio, the properties they lend to, and selling a heat pump to those homes makes the EPC worse. So at the moment, the incentives are completely misaligned.
So do I understand you correctly that EPC rating, which demonstrates how energy efficiency, quote unquote, your property is, goes up, down, it becomes worse when you actually consume less energy?
When you use a heat pump, yeah.
That's ridiculous.
That's insane,
That's something
right?
that needs to be fixed.
So the government are consulting on it, and the expectations are that in a year or so, the EPC letter, the way they calculate the letters will change to kind of come in line with reality and also our national objective, which is to decarbonise how we heat our homes. But also, so that will naturally change, and that will create a bit more of an incentive for the finance sector to start decarbonising heating. At the moment, if you go to your bank, it's really quite confusing. There's a lot of stuff about getting a retrofit coordinator to come to your home and kind of measure everything and give you lots of, which is not a bad thing to do, but it's just more stuff to do. As I said earlier, you can get a heat pump installed in your home, very high efficiency, without having to get a home energy report and then insulate your home. It's not a bad thing to insulate your home. By all means, do that. But if you want a heating system because the one you've got's broken, you don't want to perhaps wait whilst you find contractors to insulate your home.
But that also, the talk about EPC opens a nice pivot into who installs, under what conditions, and how can we incentivize them. So the guys we were talking about until now is pretty much owner-occupier. You own your house. You are the person who pays for the heating system. You are the person who benefits from either lower cost or the comfort, right? Then there are other type of properties, right? There's a huge rental market where the landlord pays for the installation, but they do not experience either low running cost or the heating comfort. And if the cost is higher for one versus another, the simple financial optimization tells you that they're going to install the cheapest heating system there is, especially if retrofitting or any kind of energy efficiency measures which are required take the flat off the market or the house off the market for a while, which is a loss of rental income on top of the cost of installation. So that's one big problem that I want to highlight.
So with private landlords, there are lots of innovations coming to support them. And as we said a second ago, if you borrow to pay for the upfront costs, then the savings on the bills can pay for the reductions. There are energy bill included business models that are being experimented with by Retrofit for Future and various other places. I'll stick it in the show notes so that the landlord can have no upfront cost to put the heating system in and then recover the costs through actually reduced rent, but including energy bills. So that the tenant benefits from a reduction in bills on their rent, but you don't pass on the full saving, and part of the rent pays for the upfront installation costs. There's also ability to kind of draw down your future rental income as a guarantee for the loan. There's lots of really interesting things happening there. There's also a stick. Government are consulting on MEES, which is basically rules for landlords renting their properties out to get the energy performance of their homes to be low carbon. So that's coming one way or another. So when you're replacing a heating system, if you're a landlord, you should be looking at a heat pump.
Well, there are some already restrictions on what EPC should be to be able to rent out the house. But if the low carbon heating system makes it worse, then it's much more of a disincentive.
At the moment, but that is changing. And in the next year, 2 years, that should change. Depends how quickly government get around to doing it. It's difficult to change this stuff, but fundamentally, anybody who works on this knows you have to install a zero carbon heating system to decarbonise the home heating. So that's happening. And
also kind of moving beyond that is we talked about retrofits mostly. What about the new building? I just want to also highlight here some of Imperial research, SafeGround. We did a project called SafeGround about ground source heat pumps led by David Tabarda and Paul Sapin, which looked at all aspects of ground source heat pumps. one big pro of ground source heat pumps is that the ground is pretty much the same temperature, especially in the winter when the air gets much colder, the ground doesn't get quite so much. And therefore, they're much more consistent performance of those systems throughout the seasons. The brilliant Imperial, and it's an inter-university grant, other universities as well participated. They pretty much determined the design of the heat exchangers to optimize the performance. So we have quite a lot of confidence in the performance of the systems. The trouble, it's still quite expensive. And you wouldn't normally retrofit with ground source heat pumps because you either need space or you need to put it in the foundation of the house. But when we talk about the new builds, residential or commercial, how do we open up space for heat pumps, air source and ground source? Is it needs regulation, or do we rely on the goodwill of developers?
Well, which do you think? I think what tends to happen when new markets are forming is that, initially it feels a bit risky and uncertain, and so, only innovators and pioneers do those things, but gradually better ways of doing things evolve and it becomes mass market, right? So there's a kind of time course to these things. You're right, though. At the moment, it's not something that every developer is doing. Many developers are doing. There's a business called Kenza that are working with councils as well, who own many properties, like on a council estate. And they've been doing that for a long time, where they'll install a shared ground loop for many different homes that are on the same estate. And it's a bit like a cross, if you like, between a heat pump and a district heat network, where the ground loop is used to power a ground source heat pump. So there are already examples of retrofitting ground source heat pumps to homes. And there's loads of innovation happening again in that space to make it simpler and easier, to make it quicker and simpler. Some of that is about the commercial model. So it's about, how do you sign up? How do you make it easy for people who live near each other to discover and sign up in advance to a loop before you've built that infrastructure, which, as you say, the upfront costs can be a bit higher because you've got to dig a hole. But there are benefits over the kind of lifetime of the system. They can last longer because there's fewer moving parts. They're much simpler. They can be a slightly higher efficiency because it's not actually at the top of the ground, which obviously does get cold, because it's touching the air, but the deeper you go, as you say, the temperature stays very stable, so the performance system stays very, very high all through the year. There's also more flexibility. So as we were saying earlier, we had this thing about electricity prices may vary quite a lot over the time of the day. With these ground source systems, you can really maximize the flexibility, really use as much of that cheap electricity as possible, store as much of that as in heat as you can, and then use it when the prices go high. So there's lots of benefits to ground source heat pumps, and there are Octopus are experimenting with this. There's a business called Deep Green experimenting with it in combination with data centers, which is an absolutely brilliant idea, using the waste heat from data centers to kind of produce some baseload heat, if you like, which is all heat pumps are doing. They're extracting heat from the air, which has some heat in it, or from the ground, or from the water, or from wherever. Ground source heat pumps are brilliant technology. That sounds like a really interesting project from Imperial. Who did you say was running it?
David Tabarda and Paul Sipin.
Yeah, one to look up. I look forward to that.
Okay, sounds fantastic. But back to the question, do we need the government to regulate and say you have to include it, or you cannot connect to the gas network? Or the developers, it's a principal agent problem, right? Developer builds it, they pay all the upfront cost, and then they sell it on. Yeah. They don't operate the building usually. Yeah. Who will install it? I
think, again, there is a lot of innovation going on in the space. So Octopus are selling, zero bills homes, working with developers. So there are pioneering developers, and they get to a zero bill home by installing lots of low carbon tech. That means your bills are very, very low, and it's included in the price of the home, basically. Government, what they can do, there's new standards coming in for building new homes, and I think there's some intelligence in how you design a policy. So you can, as a policymaker, you can say you have to install a heat pump, but probably better is to say you have to build a zero carbon home, because that second way of doing things rewards innovators who can come up with the best way of building a zero carbon home, which might be using combinations of technologies in new ways, or even, investing in new technologies we don't know yet.
So that sounds all fantastic. And we usually talk about people or organizations who can pay for their heating. There, however, is a cost of energy crisis, and there are some households which cannot afford energy bills as is, let alone high upfront cost or extra borrowing. What do we do there?
Yeah, I think that's a really important question. The government already spends billions of pounds per year trying to support people with their energy bills if you can't afford them, so fuel poverty support. And I think there's ripe opportunity for innovation in that space as well. So the Energy Systems Catapult has a Fair Future program, which has been pioneering innovation for a long time to help make sure everyone can afford the energy they need. And they've been looking at something called warm home prescription in this space, where the NHS can help find people who, if they get cold, end up in hospital and offer them help with their heating. And that makes it much, much cheaper to find people who need support. It can cost £1,000 for an energy company to find someone who needs support. And then the thing that they do is they offer to help pay the heating bill. But what they could also be doing is offering them a new heating system when they've got an old one, so that you can combine this, offers that are already available from the government to help people buy new heating systems with this more precision targeting to those who really need it and who, if they can't get warm, end up, ill, in hospital, or worse. There's a lady called Rose Chard at the Catapult who's leading on that.
Okay, and that probably will also cut on the bills of NHS of admitting those people or treating them for whatever illnesses that could have been prevented by living in a warm, comfortable home.
Yeah, as ever, prevention is better than the cure, not only for the person who's ill, but yeah, it's cheaper at a system level.
Okay. One more question is, if someone has a brilliant idea on either how heat pumps can be made more efficient or more affordable, or any other new heating, low carbon or zero carbon heating systems, what can they do?
Well, they should get in touch with us at Undaunted. We support people who have great ideas and help them turn those into small businesses and raise funding to scale them in the market.
This was a fantastic conversation. I learned so much, and I'm very excited about it. But one question I have for you is 600,000 per year by 2028 installations of heat pumps. The UK government goal. Will we meet it?
No, I think we're going to exceed it. I think that's way too low. We probably need to be doing about 1 million a year by 2030, something like that, which is a more ambitious target. And the good news is that we're seeing massive increase in uptake of heat pumps already, and we just need to continue that trend, and it will create momentum of its own. So heating engineers around the country are starting to learn how to do a really good job on this. You've seen businesses like Octopus and Aero and OVO and EDF, all of the energy suppliers investing heavily in this space. A ton of new innovations, like I said earlier, Anzen is one of many. And so you're seeing this thing which appeared to be niche. My mum always used to say to me, like, what is it you're doing now? And she wouldn't understand. Now she's saying, oh, yeah, I saw that on the telly last night, people talking about heat pumps. You've been banging on about that for ages. It's becoming mainstream, and that will lead to a step change and exponential increase in uptake.
Sounds fantastic. There's always hope. And thank you so much for sharing so much insight about this technology and UK decarbonization path with us.
Thanks, Anna. Thanks for having me on the show.
Thank you for tuning in to the Energy Futures podcast. Here at Energy Futures Lab, we are dedicated to addressing global energy challenges through pioneering research, innovation, and advocacy. To learn more about us and the exciting projects we are working on, visit our website and follow us on social media. If you enjoyed this episode, please like and share and subscribe to stay up to date with our latest content. Until next time, stay curious.